Alright, here we go now. Let's pick up from where we left off. We're still in section 2 of chapter 4. And we're going to look at some identities that I've already kind of shown you prior to this formal presentation right here. The reciprocal and the quotient identities. You need to know these. There is no way that you're going to want to stick around and do a whole lot of trigonometry without having these put to memory. Especially these three guys right here, because you should be pretty good with sine, cosine, and tangent. But the reciprocals here of each. Cosecant and sine are reciprocals. Secant and cosine are reciprocals. Cotangent and tangent are reciprocals of one another. You got to put that to memory. And it doesn't matter if you present them this way or this way, it's showing that they are reciprocals of each other. Now, also, and I mentioned this before, quotient identity, we determined that the tangent of t, well, when we were looking at a unit circle, we were looking at it as y over x, and of course the sine's the y and the cosine's the x, so y over x makes sense that it's sine over cosine, the sine of t over the cosine of t, and since again these are reciprocals, just the other way around, the cotangent of t is the cosine of t over the sine of t. I try to use some of these identities to work the following problem. Given that the sine of t is 3/7 and the cosine of t is 2 square roots of 10 over 7, use the reciprocal and quotient identities to find the values of the other four trigonometric functions of t. Alright, so the other four would be tangent, cotangent, secant, and cosecant. So let's start with the tangent. The tangent of t, well, I'm going to use the quotient identity right here is equal to the sine of t over the cosine of t. So this is equal to, I'll go ahead and write it out here. The more times you write it out, probably the better you're going to remember it anyway. The sine of t is given to be 3/7. So, by the way, if the sine is 3/7 and the cosine is 2 square roots of 10 over 7, notice both positive numbers. If this angle t is written in, put in standard position, this is a first quadrant angle. So we're going to use that because if sine and cosine are both positive, so are all the other trig functions, because the reciprocals are going to be positive. That would be secant and cosecant and secant. And of course the tangent and the cotangent, which are their ratios, are going to be positive as well, because positive over positive is positive. So I already know that all my answers should be positive, and I want to write my answers in simplest form. I do have a radical here, so I might have to write it in simplest radical form. I am not jumping to my calculator to use a decimal approximation unless the directions in a problem tell me to. The sine of t is 3/7. The cosine of t is 2 square roots of 10 over 7. Now, I have a fraction over a fraction. Remember, this is just division. So this is the same as 3/7 divided by 2 square roots of 10 over 7, or multiplying by the reciprocal. Remember, you invert and you multiply by the divisor. I remember one of my teachers, Mrs. Tarrant, back in, back in middle school, drilled that into all of our heads to make sure that we knew that when we were dividing by a fraction, you invert the divisor and multiply. And look here, I can cross cancel and simplify. I end up with 3 over 2 square roots of 10. Now, I'm not going to leave my answer in this form for this problem because I have a radical in my denominator and I can easily rationalize my denominator by multiplying top and bottom by the square root of 10. So this is 3 square roots of 10 all over 2 square roots of 10 times the square root of 10. Well, the square root of 10 times the square root of 10 is 10, so this is 20. And there's my first value. Now, really nice is that the cotangent of t is the reciprocal of the tangent of t. Let's go to where it's like here. Okay, that's what the tangent of t is, and I rewrote it because it wasn't in simplest radical form. But since I want the cotangent, this is what the tangent was, I want the cotangent, I want the reciprocal. So I'm not going to take the reciprocal of this guy, it's just going to put a radical on the bottom. I'll take the reciprocal of this form of the same exact value. And the reciprocal would be 2 square roots of 10 all over 3, and I don't have to rationalize my denominator. Now the other two, the cosecant of t, remember that is 1 over the sine of t, so that is 1 over 3/7, so that's 1 times 7/3 or 7/3. Don't write it as a mixed number, just go ahead and leave it as 7/3. It's okay for it to be an improper fraction as long as it's reduced. And lastly, the secant of t, which is 1 over the cosine of t, would be 1 all over this guy. 2 square roots of 10 all over 7. So that's 1 times 7 over 2 square roots of 10, which of course is 7 over 2 square roots of 10. Now I'm not going to stop there because I have a radical in the denominator like I did back here. So top and bottom, multiply by the square root of 10, I get 7 square roots of 10 all over 20. And that guy, and that guy, and this guy. Those are the 4 values that they're looking for. Now we're going to come up with some other identities. In fact, some other identities that are also extremely useful and you need to put to memory. And we're going to come up with them right over here. So since we're using the unit circle, x squared plus y squared equals 1 when we did our definitions, and we defined the cosine of t to be x and the sine of t to be y, if we made substitutions into here, in for x, the cosine of t, in for y, the sine of t, look what we'd end up with. We'd have the cosine, whoops, gotta write it, we have the cosine of t squared plus, plug in, the sine of t squared is equal to 1. Now conveniently, when we have a trig expression raised to a power, we can bring the exponent and put it right here in between the name of the trig function or the abbreviation of the trig function and the angle. So I can write this as the cosine squared of t, or cosine t quantity squared, plus the sine squared of t, or sine of t quantity squared, is equal to 1. This guy right here is the first of 3 that we call the Pythagorean identities. The Pythagorean identity, of course, having to do with the right triangle, the Pythagorean theorem, and that's what I'm looking at here when I'm using the unit circle and I'm talking about the x and the y. Because the x value would be one leg, the y value would be another leg, and then the hypotenuse would be 1. That's why these are referred to. And it kind of looks like the Pythagorean theorem. A squared plus b squared equals c squared kind of a deal. Pythagorean identity. That's the first one. That's the one that we'll use probably more than the other 2 combined. Put it to memory. And it doesn't matter if it's t or theta. A lot of times you'll see in books they'll write it cosine squared theta plus sine squared theta is equal to 1. It doesn't matter as long as these are the same angle. Okay? Now, let's take this guy and let's divide both sides by cosine squared t. So I'm going to divide the first term by cosine squared t. I'm going to divide the second term by cosine squared t. And I'm going to divide the right side by cosine squared t. Now cosine squared t over cosine squared t, that's just 1. Plus sine squared t over cosine squared t, that's the same as the sine of t over the cosine of t squared. And 1 over cosine squared t, that's the same as 1 over the cosine of t quantity squared. Well, that's tangent. So I have 1 plus tangent squared t is equal to 1 over cosine of t, remember, is right there, it is secant of t. So this would be secant squared t. And this is the second one, I'll put another arrow right here, of the Pythagorean identities. There are 3, we have the first 2. I'll put it over here, but this time just to keep consistent, I'll write it with a theta instead of a t. It does not matter. Okay, so we have the first 2 here. Now if I go back to the original, and this time instead of dividing by cosine squared t, I divide by sine squared t. I don't know if I left myself enough space here. Let's see if I can make this go a little faster. So I take cosine squared t divided by sine squared t, and plus sine squared t divided by itself, sine squared t, is equal to 1 over sine squared t. Well, I'm not going to go through the step where I write it as the quantity squared. I think you'll be able to follow this. This is the cosine of t over the sine of t quantity squared. This is cotangent squared t. That, of course, is the same thing over itself, 1. And 1 over the sine of t quantity squared, which is the same as this, would be 1 over the sine of t is cosecant, so this would be cosecant squared t. Back over here, I'm going to write this as the cotangent squared theta plus 1 equals the cosecant squared of theta. I use this one in trig a lot. I use this one some, this one not very often. One's kind of in a blue moon. But you should know all 3, and if you have this one memorized and you remember how I derived the other two, you can always find the other two. I remember when I took trig a long time ago, I had this one memorized, and I would have to get scratch paper out, like on a quiz or a test, and I'd have to kind of derive it really quickly to remember the other two identities. So let's put it right there. So we have those three, and those are the Pythagorean identities. Okay, now I'm going to use the Pythagorean identities, and I'm going to use it to solve this problem right down here. It says, given that the cosecant of t is equal to 5/4 for t being between pi over 2 and pi, that would put this in the second quadrant, between 90 and 180, between pi over 2 and pi. Use the appropriate identity to find the value of the cotangent of t. Well, I am using this guy right here. Look, they give me cosecant, they're looking for cotangent, that's the guy. So I'm going to substitute in, but I have to keep track of something. My angle is in the second quadrant. Cotangent is negative in the second quadrant. Do you remember from the other video, all students take calculus? In the second quadrant, sine, and also its reciprocal, which would be cosecant, positive. But tangent, cotangent, secant, and secant and cosine are negative. So this guy's going to be negative. I got to keep track of that. So now I'm going to go with this guy. I'm going to substitute in 5/4 right there. So I have cotangent squared t plus 1 is equal to 5/4, and that 5/4 is being squared. I'm squaring the cosecant of t. So I'm squaring 5/4. So I have cotangent squared t plus 1 equals 25/16. I'm going to subtract 1 from both sides. I get the cotangent squared t is equal to, now when I subtract 1, 1 is the same as 16/16, so that's going to give me 9/16. And then I'm going to have to take the square root of both sides, and I'm going to get the cotangent of t is equal to, looks like plus or minus 3/4 when you take the square root of 9/16. But remember, for this problem, cotangent is negative. So the cotangent of t is negative 3/4 is my answer. And the Pythagorean identity is the first example. Remember that one because you're going to use these Pythagorean identities a whole lot more.